Let's talk about another measure of dispersion that doesn't just show the distance between the highest and lowest values. Let's talk about a measure of dispersion that actually does measure the overall amount of spread between all of the numbers in the data set. One measure of dispersion that does measure the overall spread between all of the numbers is called the mean absolute deviation. And right now I'll list the steps to get the mean absolute deviation. First we have to find the mean of the data set. Next we have to subtract each data value by the mean. To get values called deviations. Next we have to find the absolute value of each deviation. And then find the mean of the deviations. And I'll explain what the word deviation means when I go through these steps. So first we have to find the mean of the data set. Let's do it with the population first, and then with the sample. So what's the mean of this population? To get the mean, we have to add the 5 numbers and divide the total by 5. What do we get when we add these 5 numbers? Well, the total comes out to 330. And we have to divide by 5 since we have 5 numbers. And we get 66. So the mean of the entire population is 66. Right here I'll write data, so we remember that this is the set of data. Right now we're going to subtract each number, or each data value, by the mean of 66. Maybe I'll move this down a little bit. So the reason I wrote the word mean right there is to show that each number that I'm writing in this column is just the mean of 66. Let's subtract all of these. 60 minus 66 is negative 6. 84 minus 66 is 18. 65 minus 66 is negative 1. 56 minus 66 is negative 10. And 65 minus 66 is negative 1. Let me double check these. This is correct. This one's correct. Looks like they're all correct. These values here are called deviations. They're just the answers that we get after we subtract each value by the mean. So I'll write deviations right here. I'll erase this. This is just the work we did to get the mean of 66. So now we've already finished the first two steps. We found the mean of the data set and we subtracted each value by the mean to get the deviations. Next we have to find the absolute value of each deviation. We have to get the absolute value of each of these numbers. To get the absolute value of a number, you just take the number and leave off the sign. So if it's a positive number, it just stays the way it is. It stays positive. And if it's a negative number, it just changes to a positive number. Let's find the absolute value of each of these deviations. So we'll call them absolute deviations. The absolute value of negative 6 is 6 because to get the absolute value of a negative number, you just take the number and leave off the negative sign. This value is 18, which is a positive number. If it's a positive number, it just stays the way it is. So it'll just stay 18. Negative 1 becomes 1 when we leave off the negative sign. Negative 10 becomes 10. And negative 1 becomes 1. And if we had a 0 in here, then 0 would just stay 0 because the absolute value of 0 is 0. So now we finished step 3. We found the absolute value of each deviation. Now we can do the last step, which is finding the mean of the deviations. Sorry, this should be different. It's actually finding the mean of the absolute deviations. So let's do that. To get the mean of the absolute deviations, we just add these 5 numbers and divide the total by 5. We're pretty much just finding the mean of this list of numbers right here. We add them and we divide by 5, because we're dividing by the number of numbers. There's 5 numbers in here, so we divide by 5. Let's add the numbers on top. 6 plus 18 is 24. 24 plus 1 is 25. 25 plus 10 is 35. And 35 plus 1 is 36. So 25, 24, 25, 35, 36. Now we just need to find, we added the numbers, and we got a total of 36. Now we divide by 5. We get 7.2. So the mean absolute deviation of the entire population is 7.2. I'll abbreviate like this. Now let's find the mean absolute deviation of the sample. We have to follow these same steps. First we have to find the mean of the sample. Since the sample includes 3 numbers, we add the 3 numbers and divide the total by 3. Let's add these 3 numbers. The total is 181. So we'll divide 181 by 3, and we get 60.33. So we finished step 1 and found the mean of the data set. Step 2 is subtracting each data value by the mean. In order to make this easier so that we don't have to deal with decimals, let's round this mean from 60.33 down to 60. Let's round it to the nearest whole number. So we're going to be subtracting each of these by 60, since we rounded the mean to 60. We're doing step 2, which is subtracting each value by the mean. $60 minus 60 is 0. 65 minus 60 is 5. And 56 minus 60 is negative 4. These are our deviations. I'll just write DEV. That finishes step 2. Now we need to do step 3, which is finding the absolute value of each deviation. I'll write ABS DEV for absolute deviation. The absolute value of 0 is just 0. The absolute value of 5 is 5, because if it's a positive number, it just stays the way it is. And the absolute value of negative 4 is 4. We just leave off the negative sign. So we found the absolute deviations, which was step 3. In step 4, we have to find the mean of the absolute deviations. That just means we have to find the mean of these three numbers. To get the mean of these three numbers, we just add the three numbers and divide the total by 3. We're just adding and dividing by the number of numbers. The top equals 9. We divide by 3. So we added the three numbers and we got a total of 9. Now we're dividing by 3 and we get 3. So the mean absolute deviation of the sample is 3. Remember how I said that the sample has less dispersion and the population has more dispersion? Since the population has more dispersion than the sample, that's why the population has a higher mean absolute deviation than the sample. We have a list of numbers right here, and we have a list of numbers right here. The list of numbers that has the most dispersion will have the higher mean absolute deviation, and the list of numbers that has lower dispersion will have the lower mean absolute deviation, because as the dispersion goes up, the mean absolute deviation goes up along with it. So the reason why the population has the higher mean absolute deviation is because the population has more dispersion than the sample. Now you might be wondering why we didn't just find the mean of this column of numbers. Why didn't we just find the mean of the deviations? The problem is, if you try to add the deviations, they'll add up to 0. And that'll actually always happen, no matter what list of numbers you're dealing with. The deviations always add up to 0, because the negative numbers and the positive numbers cancel out. So if you tried to add up these numbers on your own, you would see that they add up to 0. And if you tried to add up, let's see, these numbers should also add up to 0. The reason that they don't is because we rounded the mean before we did the formula. We didn't use the exact mean. But if we did use the exact mean of 60.33, then these would add up to 0. Since the deviations add up to 0, that gets you to a dead end, because once you get to 0, it's not clear what step should be done next. So the formula ends up at a dead end, and you don't want that to happen, so what you do is you find the absolute values of the deviations, which makes all the numbers positive, and then the numbers don't add up to 0. And you can actually, which means since these numbers don't add up to 0, you can find the mean of these numbers, even though you can't find the mean of these numbers over here, since they add up to 0. And if we tried to find the mean of these numbers, they would add up to 0, and then 0 divided by 5 is just 0. Now, I said that the reason that we found absolute values is to make all of the numbers positive so that they wouldn't add up to 0. There's actually another way to make the numbers positive besides finding the absolute values, and that's what I'll show you next.